So hello students, welcome once again. So today we will see the conversion of galvanometer into ammeter and voltmeter. So it clearly means that the galvanometer can be converted to both ammeter and voltmeter, but through some small changes. And this change takes place externally. It doesn't mean that we will remove some parts or tools from galvanometer and it will turn into ammeter and voltmeter. It doesn't like that. Okay, we need to make some changes in terms of adding something externally. Okay, but which type of galvanometer can changed into ammeter and voltmeter? In last video we discussed about moving coil galvanometer, and the moving coil galvanometer is also of two types. That is, one is suspended coil galvanometer and one is pivoted coil galvanometer, which is also called table galvanometer. I told which is widely used in laboratory. Okay, which works on the principle of the deflection, isn't it? On the deflection of the needle when current passes through coil, in deflection we can get the idea about the presence of any kind. So that pivoted coil or table galvanometer can be converted to ammeter and voltmeter. But before that, I think I need to tell something about ammeter and voltmeter in briefly. Okay. So we all know about ammeter and voltmeter and its function. Ammeter is used to measure the flow of entire current, actual current flowing through the main circuit, whereas voltmeter is used to measure the potential drop, that is the voltage across 2 points. You also know that is ammeter is connected in series combination with the main circuit, whereas voltmeter is connected in parallel combination with the main circuit. But why ammeter is connected in series combination, whereas voltmeter in parallel combination? Now, because what is the function of ammeter? Because the function of ammeter is to measure the flow of the entire current passing through the circuit. Since its function is to measure the actual current through the circuit, so ammeter should be connected in such a way that the entire current passes through the which is flowing through the circuit can passes through it, and it is only possible in case of series combination, because we all know that series combination provides only single path of flow of current. That's why. And voltmeter, why voltmeter is connected in parallel? Because voltmeter generally measures the potential difference across 2 points. So that's why voltmeter is generally connected in parallel combination. But not only that, then what should be the resistance of an ammeter? Now the ammeter, just think, what should be the resistance of an ideal ammeter? It's an ideal concept. So you can think about it. Okay, if you take time, I think you will be able to answer this question. Now since function of ammeter is to measure the flow of current through the circuit, so if its resistance is high, isn't it? If its resistance is high, so this high resistance will prevent the flow of current in the ammeter. So it means, since its function is to measure the current, so its property should be to allow the flow of current. So in that case, the resistance of the ammeter should be as negligible as possible. Clear? If resistance is very small, so all current can pass through the ammeter. Okay. So it means the resistance of an ideal ammeter should be 0. Ideal ammeter means it will measure the entire current. Whatever the current is flowing through the circuit, it will pass through it. It is only possible if its resistance is 0, because whatever it may be, ammeter or voltmeter or galvanometer, each contains, all works, isn't it, through the deflection of the needle. Through the deflection of the needle, isn't it, all the instrument contains coil. As I told, coil means through any frame, rectangular film, but wrapping by some insulated copper wire. So when current flows through that wire, that coil experiences some torque, and because of the torque, the pivoted coil or the pivoted pointer, isn't it, which is connected with the coil, it moves, and through the deflection of the needle, all works, isn't it? Through the deflection of the needle, we can measure the current using ammeter. Through the deflection of the needle in voltmeter, we can measure the voltage, and through the deflection of the needle in the galvanometer, we can detect the presence of current. So all works on the deflection of the needle. So in ammeter, the deflection of the needle measures the current. Clear? So since it contains some coil, so coil must have a resistance, at least some few resistance, very small, but it has some resistance. And since it is connected in series, we all know that in series combination resistance increases. So it means if its resistance is not zero or not negligible, in that case the resistance will be counted, it will add, and it will just oppose, isn't it? Prevent the flow of current. It will just prevent that current which is flowing through the circuit to pass through it. So what will be the result if 10 ampere current is flowing through the circuit, and if the resistance of the ammeter is not negligible or low, suppose 9.5 ampere current will pass through the ammeter, so we will not get the authentic current, so there will be an error in the reading. So that's why the reading of an ammeter, ideal ammeter, should be 0, isn't it? So that's why we can say that the ammeter is an instrument which is having very low resistance, okay, which is connected in series with the main circuit. Because practically, as I said, practically it is not possible to having zero resistance since it has some coil. In ideal condition, isn't it? Ideal means ideal condition, which is not possible in practical. Because it has zero resistance, isn't it? So practical, it is very low resistance, and ideally it has zero resistance. Clear? Now comes to in terms of the voltmeter. What should be its resistance? Now since voltmeter's function is to measure the voltage, it means its function is not to measure the current. Mind it, not to measure the current. So if its resistance is low, so current will pass through it, and if current will pass through it, okay, there will be some voltage drop. It means the total the voltage in the actual circuit and voltage across the voltmeter should be same here, isn't it? So if its resistance is low, current will pass, and through that current there will be some voltage drop. So it means the reading in the voltmeter, the reading of the voltage which we will get through voltmeter will be less than that of actual voltage. Same thing. So 10 voltage, suppose the actual voltage is 10 volt, and through voltmeter we will get 9.5 volt. So again there will be an error. So that's why in case of ideal voltmeter, the resistance has to be high, isn't it? Because you will have to remember through this short trick, since function of ammeter is to measure the current of the circuit, so that entire current through the circuit can pass through it, so resistance should be negligible, 0 or negligible. In case of voltmeter, since its function is not to measure the current, so its function is to measure the voltage only. It means it doesn't allow current through it. So when it is possible, if the resistance is high, we all know that resistance means resist the current. So that's why we can say voltmeter is an instrument with high resistance in compared to other instruments, and which is connected in parallel. Clear? So now we will come to the point how a galvanometer can be converted into ammeter. Now the basic fact is that a low resistance in parallel, if we connect a low resistance in parallel with galvanometer, due to lack of space I have written in short form, GM means galvanometer. Okay, just cram this line. Okay, paste this line inside your mind as well as in your head. A low resistance in parallel with galvanometer. Why? Now there are two underlined, isn't it? Two vital points. That's why I have underlined the low resistance and parallel. Mind it. Clear? Now suppose this is a circuit. Main current is flowing I. Clear? Now, fact is that if somehow due to short circuit or any reason a high current flows through the galvanometer, what will be the reason? Coil will burn and the pointer needle will just break. So to avoid this problem or risk, such a resistance, a low resistance is generally connected in parallel with galvanometer. Okay, just it is called shunt. Okay, it is called shunt. SHUNT. Shunt means alternative way, bypass, alternative way, isn't it? Take U-turn through an alternative way, alter path. This is called shunt, isn't it? We use in our life, that is by shunting we will manage it. So shunt. So what is the function of the shunt? It means if you can take this the bypass, isn't it? It means a high current flows through the galvanometer. If there is no shunt or arrangement like this, entire current will pass through the galvanometer. It will just burn the coil and the pointer needle will just break. To avoid this problem, this is done. What happens in this case? A very small amount of current only passes through the galvanometer, and the rest of the current, the rest amount of a major portion of current generally take U-turn and take the bypass, just like any bus you can imagine. Okay, suppose a bus is moving and after traveling some distance it faces some traffic jam or any bridge may collapse. So there is it takes generally some alternative way through bypass and it will reach its destination, just like that. Example. Okay, through example everything will just become very easier. You will have to just find it. Example. So in the same way, the huge current, only small current, because to deflect the needle of the galvanometer, only small current is enough. So that's why it is that. So shunt is an alternative path through which a majority portion of a current can pass through. Okay, and save the galvanometer from getting damaged. Clear? So suppose I is the amount of current, here G is the galvanometer, G is its resistance, and so total current is I. The required current for deflection of the galvanometer needle is Ig, and the rest amount of current I minus Ig is flowing through the shunt. Now the question is why low resistance and parallel? Okay, you will have to listen it very carefully. Now low resistance, why? Now one fact is that we don't know about ammeter. Okay, because you don't know. Suppose, okay, for logic, suppose for assume you don't know, we are going to turn it into ammeter. Low resistance means what is our motto, what is our purpose, goal is to save the galvanometer, okay, to save the galvanometer from flowing the high excess amount of current. Clear? Now since we all know that the current always flows, since only a small portion of current is passing through the galvanometer, our goal is to allow only a small amount of current. If intercurrent passes through the galvanometer, a huge current passes through the galvanometer, in this case galvanometer coil may burn and pointer may break whatsoever. So majority portion of current should pass through the shunt, that is in alternative way. So since current always flows through a low resistance, it always search for the low resistance path, because high resistance opposes the current. As everybody will know that, we all know that current only can flow through a low resistance, isn't it? Because low resistance allows the current to flow. So that's why it is low resistance. If it is high resistance, it cannot pass through that, then it will just return back, isn't it? It cannot take the bypass route. Why is it parallel? Why is it parallel? Because if it is connected in series, mind it, if it is connected in series, then it has some amount of resistance, then that resistance will be added to galvanometer, then its resistance will be increased, and since our function is to turn into an ammeter, so again what will happen? To decrease the resistance, in case of ideal ammeter or any ammeter, isn't it? Ideal ammeter is zero resistance, but the resistance of the ammeter should be as less as possible, because it is going to measure the entire current. So if it is connected in series, so resistance will be increased. In that case, its reading will be less than the actual current. Current will be 10 ampere and it will measure 9.5. So it will be a faulty ammeter, isn't it? Like that. So that's why it is connected by low resistance, and in parallel it will turn into an ammeter. Clear? Now let's see the mathematical expression. Now we will apply Ohm's law across this AB. Clear? Since potential difference is same, so applying Ohm's law, that is Ig is current flowing through G through galvanometer, whereas rest current I minus Ig, total current Ig current flows through G, so rest current I minus Ig generally take the bypass road and flowing through S. So Ig into G is equal to I minus Ig into S, since both are connected with the same terminal, potential difference is same. So calculating here, we get this, and Ig is the required current. Ig, G for galvanometer, it means the current flowing through galvanometer which produces deflection in the galvanometer. This is okay. So S is equal to this, the resistance of the shunt is this means. So it means only S divided by S plus Gth part of the total current is enough. Okay, generally flows through the galvanometer and produces this deflection. Clear? So it means for deflection of the galvanometer needle, total actual current in the circuit is I, whereas Ig is the current flowing through the galvanometer. Clear? Is it clear? To produce deflection in the galvanometer needle, Ig is the current which flows through the galvanometer, where I is the total current. So here in this case, we can say that is it's the range. So now it is turned into an ammeter, and what is its range up to which it can measure the current? From 0 to I ampere. Why? Since I is the actual current flowing through the circuit. Clear? Now if 1 ampere, suppose, okay, for an example, now suppose 1 ampere is, okay, suppose 1 ampere current is enough to produce deflection in the galvanometer needle. So this is 1 ampere. Clear? So, and if we want to convert it, if we want to convert this galvanometer into an ammeter which can measure up to 10 ampere, isn't it? We want to make this ammeter up to measuring the range 10 ampere, and 1 ampere current flowing through the galvanometer is producing deflection. So 10 minus 1 G. So here we can write S is equal to 1 by 9G, isn't it? S is equal to 1 by 9G. So the resistance of the shunt should be 1 by 9th of the galvanometer. So isn't it? Its resistance is less than that of galvanometer. One hand, its shunt is a small resistance, and when it is connected in parallel, it will be more or less. So that's why the resistance of an ammeter is low, whereas we can say that the resistance of this shunt is less than that of the galvanometer. You can see G by 9, 1 by G is equal to G by 9. So whatever be the resistance of the galvanometer, if we divide it by 9, you will get the resistance of shunt. Very low resistance. So in this way, a galvanometer can be easily converted into an ammeter. What I said, through some external changes, adding. What is that adding? That is by adding a low resistance in parallel with the galvanometer. Clear? Now moves on to voltmeter. Clear? That is high resistance in series. Again, underline high resistance in series. Why high resistance in series? Since voltmeter function is to not to measure the current, you have to remember by this. Its only function is to measure the voltage, not to measure the current. So since not to measure the current, it means its function is not to allow current, and it is only possible when it is high resistance. If low resistance, current will flow, then there will be voltage drop, then the actual voltage drop, okay, then the voltage drop through this so-made galvanometer, that is voltmeter, will be less than the actual voltage. As I said, if the voltage drop is if the actual voltage is 200, then through voltmeter we will get 190. It means less because of flow of current. It cannot tell, because if there is any flow of current, it will be voltage drop. So that's why it's high resistance. High resistance, it will not allow to flow any current, since it is not ammeter. Voltmeter, its function is not to allow current. In series, why it is connected in series, isn't it? Now, because it is connected in series, so that, isn't it, since it's a voltmeter, because it is not taking, isn't it, the current cannot pass, since here there is no, here in this case there is no bypass, here there is no bypass. Clear? And since there is no bypass here, so whatever a small amount of current, so whatever be the current here, it will just pass through, isn't it? It will just pass through galvanometer. Suppose I is the current, here the main current that is saved, because since there is no bypass here, since it is not shunt, there is no alternative path. So whatever be the main current, it will just pass through galvanometer. So that's why it is connected in series. Okay. Why in series? High resistance. If it is connected, isn't it? Just you have to remember in case of ammeter. Why parallel? Because it was in series. If we connected in series, its resistance is increased. Resistance increased means it will oppose to flow in the current, which will oppose the function of ammeter. Opposite, isn't it? Violating the function of ammeter. It is in series means some resistance is connected in series. So it means its resistance is increasing. Again, which will just oppose to flowing current. Both are double feed, isn't it? Double fence, isn't it? Double obstacle, isn't it? Low resistance current can easily take through bypass, and in parallel means if it is connected in series, then it will increase the resistance, then current cannot pass through the ammeter. Here high resistance, current cannot pass. In series, resistance will also increase, isn't it? If it would connected in parallel, resistance would have been less. We all know that in case of resistance, if a high resistance connected in series, in parallel, then reciprocally its resistance would less. If it is less, current can easily pass through, then which will violate the function of voltmeter. So that's why it is connected in series with galvanometer. So this is the arrangement. Total current, since it is connected in series, so whatever be the main current, it will just follow through the galvanometer. Clear? But it is since it is high resistance. Now if we take the voltmeter, applying Ohm's law again, so total voltage equals to total current flowing through the galvanometer plus total resistance. Okay, since this is high resistance. Clear? It can be here also, no problem. Clear? So V is equal to Ig into G plus R. Clear? V equals to IR, where R is the total resistance of galvanometer plus resistance of the external high resistance. So from here G plus R is equal to V by Ig. So this is the required value of the external resistance, V by Ig minus Z. So it means in this case the range of the voltmeter will be from 0 to V. Clear? So in this way a galvanometer can be turned into ammeter and voltmeter. A low resistance is parallel with galvanometer, will convert it into ammeter, whereas a high resistance in series will convert the galvanometer into voltmeter.